let me consider this problem. So there is a boat race. So boat A is leading boat B by 50 meter. So you can able to see here. So both boats are traveling at a constant speed. So beginning its speed is constant at t is equal to 0. So when t is equal to 0, the boats accelerate at constant rates. So both boats are accelerating at constant rate. Okay. So what happens? Knowing that B passes A, t is equal to 8 seconds. So you can be able to see that if this boat is passing this A, that is, if it is covering this 50 meter, it takes around 8 seconds. And the velocity of boat A is given, so which is around 225 kilometer per hour. They're asking you what is the acceleration of boat A and boat B. Right? This is your data. So in this, what are the things it is available? They are given what is the value of S. So S is the distance. So distance is 50 meter, right? And they mentioned that so at the beginning stage, right, you have a constant speed. Both the boat is having constant speed, right? In that case, so for boat A, so let me put U. So in the bracket, I will put A. So indicating that this is for boat A, right? So initial velocity. Similarly, U for boat B. Both are same, which is 180 kilometer per hour, right? So you convert it to meter. So into 1000 divided by 3600. So what is UA?
50, sir. 50.
Sorry,
50.
50. Okay,
Yes, sir.
50 meter per second, right? So we are getting this initial velocity as 50 meter per second. After that, your boat is accelerating, right? So they say that this is your beginning stage. They are taking the time at this stage, which is t is equal to 0. Now it is accelerating. So when both are accelerating, your B passes A at t is equal to 8 seconds. So these are the conditions, right? So and the velocity of boat A is also given when it is passing, right? So these things are given. So now, so let us go for each boat separately. So let me consider boat A. So you know what is the values here, right? So you know what is your values. So your U, what is your U value? U is 50, right? So acceleration is same. There is no difference. When t is equal to 8 seconds, when t is equal to 8 seconds, you get V value. So V value is different. So what is the V value? 225 kilometer per hour, right? What is your V value?
62.5 meter per second, sir.
62.58 meter per second. So what I have to do? I have to multiply by 1000 and I have to divide by 3600, right? So convert to meter per second. So when you do that, you are getting V value. So now I got these three values. So V, U, and T, right? So don't consider yes. Yes is different. You can't able to use yes for A. Yes is applicable only for B because we don't know what it is traveling, right? But they are given this value, right? So you have to consider that alone. So these are the three data. So what is the formula we can use? We can use V is equal to U plus AT, right? So V is 62.58, U is 50, plus A is what we are going to identify, and T is 8. Okay. So let us identify what is the value of A. So A will be 62.58 minus 50 divided by 8. So what is your A value? So A is 1.562 meter per second square, right? So this is the value of A. So we have completed this part, right? So what is this? This is for, I think, for A, for boat A. Okay. So next we will go for boat B. So go for boat B. If I consider boat B, right? So what are the data we have? We have S now. So your S is 50 meter. That is given. Next, you know what is your U value. So U is also given, which is also 50 meter per second. And you know what is the time. So time is 8 seconds, right? So which formula can we use for this one? So we have to identify what is your acceleration. So
So
S
S
is
is
equal
equal
to,
to T plus half AT square.
yeah, we can use S is equal to ut plus half at square, right? So you know S, you know U, you know T. So only unknown data is A. So you can easily identify that. Okay, so I can substitute it. So 50 is equal to 50 into 8 plus A divided by 2 into T square. So 8 square, right? So what is the value of A? Sorry. I think we made a small mistake. What I am going to identify is, so you see that B is passing A. In that case, it is 50 plus what is the distance traveled by A. So that also you have to consider, which means I have to identify what is the distance traveled by A also, right? Let us use the other formula. S is equal to ut plus half at square. So we know all the data. So let us identify what is the value of S. U is 50. Time taken is 8 seconds, right, to complete it. So plus half into A is what we identified, 1.562 into 8 square. So what is the value of S now? So it is like this boat is traveling at a particular S value. So your B has to cross both, right? This 50 plus this S value, right? So that it will overtake. Okay, so you have to know what is the value of this S. So you are getting 450 meter, right? So our S is around 450 meter. So in this case, now your B should be 450 plus 50, right? So that will be the total S distance which has to travel, which is 500, right? So S has to be 500. So I have put another zero here. That's it, right? So what is the value now? So your A is 3.125 meter per second square, right? This is the value, right? So this is the value for boat B, for B, right? So as the questions ask, they ask only for acceleration. So we have completed, we identified for both. We consider here. So here there are splits of data. So you have to split it accordingly, right? You have a train which starts from rest at station A and accelerates so 0.5 meter per second square for 6 seconds. Afterwards, it travels with a constant velocity for 15 minutes. It's then decelerates at 1 meter per second square until it is brought to rest at station B. Right. So this is the condition. So they are asking you to determine the distance traveled between the stations. Right. So it is like, let me consider. This is my point A. Right. From point A, it is moving it. Right. So this is my point B. Right. In this, though, when you want to move from A to B, there are three cases now, right? What are the case? So you have a constant acceleration, right? So let me consider this point as C. From A to C, right? You have a constant acceleration of zero point 0.5 meter per second square, and the time taken for this is around 60 seconds, right? After that, what happens? It is moving at a constant velocity of 15 minutes for 15 minutes. So let me consider another point, which is D. From C to D, so your velocity is constant, right? Velocity is uh, constant, which means whatever the velocity we identify, that will be constant. So v is equal to c. What about your acceleration? Acceleration is zero in this case, right? Because when your velocity is constant, you don't have acceleration. But you know what is the time? Time is 15 into 60. So I am converting to seconds. Right? This is my second case. Afterwards, there is a third case. So third case from D to B. If I consider from D to B, your acceleration is reducing. So it is minus 1 by 1 meter per second square. Right? So why I put minus is, so what are the formula we substitute? V is equal to U plus AT. So here your A is a negative term because it is decelerating. So that's why I'm putting a negative sign. Right? So until it's rest. So that is the thing. So which means your final velocity is also known, which is zero. Right? Your final velocity is also known, which is zero. Similarly, here also it starts from rest. So your initial velocity here is zero. Right? So these are your overall terms. So which is having. So which means I have to solve it one by one, part by part. Right? So first I have to identify what is your the part AC, then what is for part CD, then DB. So when you do that one by one, so in all these things, I have to identify what is the value of distance S, right? What is the distance in all these three cases? Then adding all these things, you will get what is the answer for it, right? So now we'll go one by one. So first, I'm going to identify what is the distance from A to C, right? So this is my location, this is my point A, and this is my point C. What are the data given? So from the given data, we identify U is equal to 0. Your time is known, which is 60 seconds, right? And you know what is the acceleration. So acceleration is zero point 0.5 meter per second square. So these are the three values which is known, right? So next, what about the other data? So I want to concentrate on V. Let us identify two more data which you have to find out. So you have to identify V value and what is your S value. These are the two data which is missing. We'll identify these two, right? To identify value, what we can do, I can use the formula. So my formula is V is equal to U plus AT, right? So which is V is equal to U is 0, is zero point 0.5 into 60, right? So you will get V is equal to 3 meter per second, right? So I identify what is the value of V, right? That is over. So next, I had identify what is the distance, right? What is the formula we can use? We can use S is equal to UT plus half AT square, right? So you are U 0, so which means this get cancelled, so which is equal to 900 meter. So so which is equal to, I think it is zero point 0.5 by 2 into 60 square, right? So we'll get 900. So these are the two datas we identified. Now we'll go for the next part, which is CD, right? So go for CD. So CD is something like this. So we have this location from C to D. My initial velocity here is what is the final velocity in your previous case, which is 3
3
meter per
meter per
second,
second.
right? And
Sir, sir, அங்க 30 வரும் sir. Initial velocity.
0.5 தானப்பா?
0.5 into 60.
Okay, 30.
Yes, sir.
Okay, sorry. So 30. So which means this will also be 30, right? So V is equal to 30 meter per second. And you know what is the acceleration. So let us write what are the data. So VU is equal to 30, A is 0. So V is also 30 because it is having uniform velocity. So both are 30. And you know what is the time taken. So time is also given, right? So time is 15 into 60, right? What you are getting?
900, sir.
900. So 900 seconds. So only data unknown is your S value. Let us identify what is the value of S. So where S is equal to, we know the formula, ut plus half at square, right? So S is equal to U is 30 into 900. So because this gets cancelled, your area, so your acceleration is zero. So this is zero, right?
27,000.
Sorry,
27,000.
27,000. So this is 27,000 meter. So this is my second term, CD. So that part is over. Next we have DB. So let's go for DB.
Sir, one more zero will come, sir.
Okay, sorry. Okay, so next DB. And I consider DB. So my location D and this is my B. My initial velocity is same like your previous one, which is 30 meter per second. Final velocity is zero. And you know what is the acceleration that is also given. Your acceleration is minus one. Acceleration minus 1 meter per second square. Right? So the remaining two data, so unknown data is your S and what is your time T. Right? So let us identify that. So what is your S value and T value? So U is given 30, V is given 0, and A is given which is minus 1. We use V is equal to U plus 18. Right? So 0 is equal to 30 minus T. Right? So which means your T is equal to 30 seconds. Right? So we identify what is the time taken. Right? So the next thing is I have to identify what is our S value. So we use the next term, which is S equal to UT plus half at square. Right? So make sure, so I am putting plus here because my acceleration is negative. I have mentioned as negative. Right? So sometimes you don't put minus here and another minus, make it as minus into minus plus. Right? So that will be a mistake. So make sure you follow that particular order. So whatever you take, right? Sometimes in deceleration, you can also put minus. It doesn't matter, but you have to substitute that A in a positive value, right? So that will be a problem, right? So you do it correctly. So S is equal to U is 30 into seconds. So T is 30 plus of into minus 1 into 30 square, right? So your S will be equal to, I think, 3 is a 900,
450, sir. Finally.
450, sir.
Minus
450.
450.
So your S is 450, right? Okay, we identified all these values. Only thing is I have to identify the total distance. So total distance covered, right, will be equal to. So for distance covered in AC, which is 900 plus your CD, which is 27,000 plus 450, right? So what is the total distance now?
28350, sir. 350
28350
meters.
meter, right? So this is my total distance. Sometimes they will also ask what is the total time taken. It is not in the question, but we have to identify that also. Sometimes they may ask you. So in that case, I have to add all my time. So my first time is 60, 60 plus 60 plus
900
900
plus
plus
30.
30. So 60
980.
plus 900 plus 30. So what is the value?
990, sir.
Okay. 990 seconds. So total time. Okay. So you may sometimes some questions they may also ask what is the time, right? So this is the another part. So by splitting it, so because of different category of velocity and acceleration, you have to split the problem accordingly and do it one by one. Consider this problem. A boy throws a ball straight from a top of 12-meter high tower. If the ball falls past him 0.75 seconds later, determine the velocity at which it was thrown, the velocity of the ball when it strikes the ground, and time of flight. So what is the time taken? Right. So it is like you have a tower. So let me consider there is a tower and this is the ground. Right. The height of this tower around 12 meter. Right. So a boy is throwing a stone from here. Right. A ball. Sorry, a ball from here. He's throwing it. So let me consider that it is straight. Okay. So when he throws, it goes up and again it is falling down, right? Up to this. So when it passes him, the time taken is mentioned as 0.75 seconds. Then it goes and hits the ground. Okay. So the question is, what is the speed? What is the velocity? Initial velocity when it throws towards the top, and what is the final velocity when it strikes the ground? Problem into two. So from A to B. This is the first two conditions. We took this. So this is what we use some formulas. So what are the formulas we used? We use that E is equal to U plus AT. So what are the datas we have? So you don't have U velocity. Let me consider this as U itself. We have time, which is 0.75. And we missed one data, which is your S. So initially my S is 0 at this location. It is going up and coming down, right? So what is my S? So we related to A and B. If I relate A and B, A is my initial position, B is my final position. So your displacement with respect to this thing is 0, right? So which means your S is 0. Right? This data we have not entered previously, right? So we consider S as 0. So A we know, which is minus 9.81. Now we use the formula S is equal to UT plus half AT square. So S is 0 here. U I don't know. T which is known, which is 0.75 plus. So sorry, it is not plus now, it is minus. Right. So what I'll get? I will get minus 4. So minus 4.905. So 9.81 divided by 2, we'll get 4.905 T square. So T is 0.75 the whole square. Right? Can you able to identify what is the value of U?
Sir,
What is the yes?
sir, one doubt, sir.
Yeah.
Sir, initially when we are throwing the ball up, sir, the acceleration will be negative, and when it is coming down, acceleration will be positive. No, sir. Will it affect when we put minus sign in this AT value,
No, no,
sir?
no. So what you have to do is you have to consider only the initial term,
Okay, sir.
only the initial value, not the final one. Always you consider your initial value,
Okay, sir.
right? So in that case, it is negative only.
Yes, sir.
Yeah. So what is your U you are getting? So you are getting 3.678 meter per second, right? So now we identified what is the value of this U. Now I'm going to consider the next data, A. So my location is now from A to C. A is my initial location and C is my final location, right? In that case, you can able to see that what are the data we have. We have U, which is already identified, same value of U, which is 3.678 meter per second. V value is not known, so let me consider that a V itself. Time I don't know, let me consider as T. Acceleration I know, which is minus 9.81. Distance I know. So this is my initial position. This is downwards, towards downwards. So it is minus 12. My distance is minus 12. For example, if they ask at this particular location, for example, what is the velocity, right? At this particular distance, 1 meter or something like that, then it is a positive value, right? So they are asking, so this is my initial location. Final is towards downward, so which is minus negative, right? So the downward is based on the arrow. Be clear, the downward is always based on the arrow. So towards that positive arrow, positive, opposite to that arrow is negative, right? So which is minus 12 meter, right? So now we will use the equation, same equation. S is equal to ut plus half at square, right? So this will identify what is the time now. So minus 12 is equal to 3.678 t minus 4.905 t square, right? Bringing on other side. So you'll get 4.905 t square minus 3.678 t minus 12 is equal to 0. You have a quadratic equation. So solve this quadratic equation to identify the value of t, right? You have in your calculator. You can go to a calculator mode, equation mode, change your equation mode to degree, 2 degrees, mention these values, you will get what is your t value. Can you tell me what is the t value? 1.8 and minus 1.23, right? So these are the two values. So we have to consider only the positive value.
Sir,
So which means this is my
1.98, sir,
value.
first.
So 1.98 seconds, right? So always consider the positive value. So my t, time of flight to reach the ground is 1.98 seconds, right? So we identify this. Now it is easy to identify what is my v value. So v is equal to u plus at. So v is my final velocity, which is equal to initial velocity is 3.678 plus, sorry, minus 9.81 into 1.98. So what is your v value? Minus 15.74 meter per second. The negative indicates the velocity is downward direction. It is opposite to the initial velocity direction. Initial velocity, it is upward. So the final velocity is negative, which means downward velocity. Okay. So this is the answer. So I think yesterday, did you get the same answer?
Sir, I got 15.344, sir. The decimal point
Oh,
only changed, sir.
okay, okay. Other than this, all the data is the same, right?
Yes, sir. Everything is same, sir.
Okay, then there is, I think there is no issue in that,
Yes, sir.
right? So you can also solve in other way, like instead of AC, I have considered AC, right? Instead of AC, I can also consider BC. That is also possible. So if I take BC, BC is from here, it is going downward. Only this location you can able to see here, from B to C, right? So if I want B to C, if I want B to C, what I have to do is I have to identify what is my S value. My S is a positive value. My S is a positive value, right? Which is 12. 12 meter, right? And your U is your initial velocity, which is this location. At this location, what is my initial velocity, right? That I have to identify, right? That I have to identify. How to do that? So from this equation, so from AB, I can identify that. I can put V is equal to U plus AT in this. So 3.678 minus 9.81 into 0.75. So 0.75, yes. So what is the value you are getting here? You are getting minus 3.67.
Yes, sir. Correct.
Yes. Okay. So same value. So now the direction what you consider is as a positive 3.67. So 3 minus indicate downward direction. So 3.67. So E is 3.67. Right. So if I consider V, right? So I can use this formula V square is equal to U square plus 2AS. Now it is plus because my acceleration is downwards, right? My A is positive plus 9.81, right? I have split it into B to C, right? That's why. So V square is equal to 3.67 the whole square plus 2 into 9.81 into S is also positive, which is 12 meter, I think so. Right? S is 12 meter, right? 12. So what you are getting? What is my V square? 248.96.
96.
So what is your V then?
15.778.
15.778. So meter per second. So you will get the same value similar to this, right? So you can also go like this also, right? It is up to you. You have lots of way to solve this problem. So you take proper values, make sure you use your data accordingly and you can try it out. Okay. So any doubt on this?
No, sir.